Welcome back, sharp minds. Today marks an incredible milestone on this channel. We have officially hit question 25 in our ultimate daily JEE Main math marathon. That is 25 high-level tier 1 concepts completely dismantled together. If you want to run a high-octane revision session this weekend, open up our full playlist and play those 25 videos back to back at 1.5x speed. It's a single best way to lock in your calculation reflexes. Now look at question 25 on your screen. We have a heavy fractional expression. If you have watched question 12 of this series, this question should immediately feel familiar. At first glance, the expression looks much more complicated. There's a product of cosines in the denominator, the angles have changed, and the algebra looks intimidating. But underneath all that complexity, JEE is testing the very same idea. The question is, can you recognize the pattern before getting lost in the calculations? Let's think sharp.
Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
So this is the given expression. Let us call it n by d, where n is the numerator and d is the denominator. Look at the numerator phase. Root 3 cosec 20 minus sec 20. If you rewrite this as sine and cosine fractions and then combine the terms over a common fractional denominator, we get this. Can you recall what specific scalar factor do you need to pull out to force a clean compound sine transformation? We apply a classic conversion trick. We multiply and divide the top numerator expression by 2. And recognize that sine 60 degree is root 3 by 2 and cos 60 degree is half. This fits perfectly into the sine subtraction compound angle identity, that is sine A minus B, where A is 60 degree and B is 20 degree. So that gives me 2 sine 40 degree. Now look at the fractional denominator of the numerator block. We have sine 20 into cos 20. We can convert this using the sine double angle formula by multiplying and dividing by 2 again. So this becomes half of sine 40 degree. So the numerator of the expression becomes 2 sine 40 degree divide half sine 40 degree. So sine 40 degree gets cancelled and we are left with just 4. Now let's solve the denominator. We know from standard trigonometric values that cos 60 degree is half. So substituting this converts the denominator into this. There is a classic highly powerful identity for products of cosine with doubling angles. Now notice the remaining angles, 20 degree, 40 degree and 80 degree. Each angle is exactly double the previous one. So this layout perfectly triggers the classic continuous cosine product identity, which is this. And we get this, which simplifies to sine 160 degree by 8 sine 20 degree with the half outside. Next we apply the supplementary angle identity, which states that sine 180 minus a is equal to sine a. This shows us that sine 160 degree is basically sine 20 degree. So let's substitute this back into our fractional block to cause an immediate variable cancellation. See? Sine 20 gets cancelled from numerator and denominator. So the denominator just becomes 1 by 16. Now let's combine our completed blocks back into our main expression. So it becomes 4 divide 1 by 16, which gives us 4 into 16, that is 64. So the correct choice of this question is option C, 64. Always segment complex fractions into standalone operational blocks to keep your steps organized. If you successfully unmasked the compound angle transformation during our opening check, drop a thunder in the comment stream below. Make sure to smash that subscribe button, turn on your notifications so you never miss a daily drop, and I'll see you tomorrow for question 26. Keep pushing, stay consistent and always think sharp.